We choose to go to the moon, not because they are easy, but because they are hard.
Hello everyone. Today in this video we are going to talk about electric current and we'll understand how metals conduct electricity. So let's start the video. So first thing we need to understand is what is current. Current is nothing but it's a flow of charge. So charge may flow through solid conductors, it may be liquid conductors like electrolytes, or it may flow through gas. So basically in this we'll talk about the solid conductors, how metal conducts. So this is atoms inside any material, but in metals there are some electrons, we call them free electrons, which can come out of atom if they get energy from the surrounding in terms of heat. So as you can see in the picture, so some electrons, they are jumping from one atom to another. Let's see in the animation. So this electron you can see is going from one atom to another. So all the atoms may have one or two free electrons, so they will move in this fashion. But the problem out here is they are not moving in one direction, they are moving randomly, so they don't give current because they are not going in a particular direction. As the current going in one direction may be cancelled by the current due to the electron which is moving in the opposite direction. So there will be no velocity, average velocity, and there will be no current in a normal conductor which is not connected to any battery. But so if a potential difference is applied, this electrons slowly start drifting in one direction from negative to positive, but they don't move straight, they move in a random fashion, but they slowly drift towards the positive terminal. So there will be current due to the motion of charge in a particular direction. So as I have described, same thing is written, you can pause and copy this. So this is how metal conduct. Because of free electron, they move in the presence of electric field or potential difference, and they start moving and they give current. Now there are some few terms related with current which we should know. So first thing is, as we know, they are drifting from one point to another point. So the average velocity which they drift from one point to another point is called drift velocity, the velocity with which electron drift from one point to another point of a conductor. And there is another term related, and if you can see small, this red electron, it's colliding two times. So in between there will be some time, it will take some time, so this time is called relaxation time. So it's a time between two successive collision, so whatever time it will spend will be the relaxation time. So the two terms are drift velocity and relaxation time. So you can pause the video and copy the definition. So now, is a conductor charged? So as we all know, the conductor, there are lots of charge moving inside. So is it charged or it's neutral? So let's see. So this is a conductor I'm taking, and right now it is not charged, it has got equal number of electrons and protons, but some electrons may come out of the atom, but it is not making it negative because it is coming out of the neutral atom, making the atom positive, and this free electron can move. Now when you apply the potential difference, this free electrons start moving. So as such, I have not given the charge from outside, so this cell will also not give the extra charge. So only this cell is making the free electrons flow through the circuit, but it is not giving any extra charge. So a current carrying conductor is not charged. And another thing I want to discuss is effect of temperature on drift velocity and relaxation time. So as we all know, a conductor consists of atom, and free electron can move through the conductor. So when we increase the temperature, this atom start vibrating. It makes difficult for electron to move through this, so it will increase the resistance of the conductor. So increasing resistance means electron cannot move easily, so their drift velocity will decrease, and because of this vibration they frequently collide, so the number of collision will increase, so relaxation time will decrease. So as you can see in the picture, if you increase the temperature, drift velocity and relaxation time will decrease. So now the direction of current. So by definition the current is flow of positive charge, but inside a conductor electrons are flowing, so we take the direction of current to be opposite of direction of flow of electrons. So in this picture electrons will move from negative terminal to positive terminal, but we take current to be flowing from positive to negative. So though the electrons are flowing, but we take the direction to be opposite. So, and current has both direction and magnitude, as we all know. So it moves from positive terminal to negative terminal, but we don't consider it to be vector, because in vector what happens is the resultant vector depends on the angle between the two vectors. But in current, suppose 2 ampere and 1 ampere is flowing through these two conductors, so every time the current in this conductor will be 3 ampere, no matter at what angle you will keep them, either you keep them this way or straight way, so every time current will be 3 ampere. So that means it does not obey vector law, meaning that the total current will not depend on the angle between the wires. Okay, I think this is the end of the video. Please don't forget to like and subscribe.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.